Welcome to part 2 of 3 of our Natural Aquifer SuDS System CPD, delivered by Hydro Rock Solutions. First, let's quickly recap what we covered in episode 1. We learned about the highly innovative Dutch Natural Aquifer SuDS system, what led to its development and how it's being implemented across Holland. We examined the changing SuDS landscape, in particular how regulation is rapidly moving towards greener and more stringent environmental SuDS standards. We looked at the key elements of international SuDS best practice and the PAD test for evaluating and selecting effective SuDS systems. Finally, we looked at the properties of a natural aquifer system. In this episode, we shall be examining the key features and benefits of natural aquifer SuDS, understanding what makes them the most cost-effective, most efficient and greenest SuDS solutions. Let us begin with a quick overview of the 6 primary benefits of natural aquifer SuDS. Fully installed cost is a minimum 20% cheaper over any available alternatives. Flooding is prevented through highly efficient buffering of storm water runoff. It is truly green, made from a totally natural material that is completely recyclable. Efficiently filters road surface runoff, cleaning up particulate matter, chemical pollutants and metals. Holds 94% water, creating highly absorbent natural aquifers wherever they are needed. Enables proper stewardship of rainwater by utilising proper on-site water management techniques. Firstly, natural aquifer SuDS comprises a highly effective 3-phase filtering system. Phase 1 uses the Hydro Rock Inlet Drains removable filter unit to prevent natural materials like leaves and sediment from entering the natural aquifer module. Phase 2 uses geotextile material wrapped around aquifer blocks to prevent ingress of particles of silt and sand into the Hydro Rock mineral wool. Phase 3 uses the natural ability of the Hydro Rock mineral wool to filter road runoff, greatly reducing pollutants entering soil and watercourses, making it the best choice for environmentally friendly natural SuDS systems. Such pollutants include dissolved chemical contaminants such as polycyclic aromatic hydrocarbons, PAHs, from car exhausts, heavy metals such as zinc and copper, and solid particulate matter produced by abrasion of moving parts such as brakes, clutches and tyres. Following on, 2 key features of the aquifer blocks are that they are both lightweight and strong. Aquifer blocks come in 2 densities: standard density hydro rock weighing 75 kilograms per cubic metre and high density weighing 120 kilograms per cubic metre. Their lightweight nature means that even the largest aquifer block, capable of holding 440 litres of water, can be lifted and installed with ease by one man, making them very fast and simple to install by hand. Aquifer blocks are very strong. High-density hydro rock can support 4 tonnes direct loading per square metre, and standard density hydro rock can support 2 tonnes direct loading per square metre. Load carrying capacity grows rapidly with increasing installation depth. This means that high-density blocks with weight-spreading mesh installed 35 centimetres beneath the road surface can easily support the heaviest UK road vehicles. In most other non-highway situations, standard density aquifer blocks can support everything demanded of them. Next, we're going to explore the aquifer block's absorbency, suspension and infiltration properties. We're now going to take a look at a short video that demonstrates these 3 unique critical properties of aquifer blocks. The first property is the high absorbency of aquifer blocks. Note the water level marked by the red line. Watch how rapidly the aquifer block absorbs water and the resulting water level barely moves above the red line. This is because aquifer blocks absorb 94% water of their cubic volume. Such high absorbency also means water moves freely between touching aquifer blocks and capable of travelling 200 metres through aquifer blocks within 24 hours. The second property is the suspension of water within aquifer blocks. Watch as the aquifer block is lifted out of the water. Note how far the water level drops. This is because the water held is suspended in the capillaries between the mineral wool fibres. Suspension of the weight of the water means that there is very low hydrostatic pressure on the soil beneath the bottom of the aquifer block, preventing soil compression. Finally, the third property is the infiltration efficiency. By preventing soil compression under the aquifer blocks, infiltration is enabled across both the bottom and the sides of the aquifer blocks. Watch how readily the water infiltrates into the sand beneath the aquifer block. The combination of these three unique capabilities make Natural Aquifer Block SuDS the most highly efficient infiltration system available. Now let's look at the installation and lifelong reliability features of the aquifer blocks. Natural Aquifer SuDS is essentially a non-engineered solution. The Aquifer SuDS system was deliberately created to make installation simple, quick and easy, avoiding any need for specialist skills, equipment or tools. Trenches only need to be 5 centimetres wider on each side than the aquifer blocks, minimising excavation, backfill and removal of spoil. This also has the benefit of allowing blocks to be placed in small, narrow areas. Aquifer blocks come ready for immediate use, individually pre-wrapped in geotextile membrane. They're simply placed on the bottom of the trench on top of a thin layer of sand, connected in seconds using snap-together fittings, then immediately backfilled. This makes Natural Aquifer SuDS the ultimate plug-and-play system, saving a minimum of 50% installation time over any alternative. Aquifer blocks provide lifelong maintenance-free operation, with no requirement for inspection, remediation, repair or replacement. They provide lifelong reliable operation at design specification reliability. All this means Natural Aquifer SuDS systems are highly cost-effective, saving a minimum 20% of total installed cost compared with current alternative systems. Another key feature of the Natural Aquifer SuDS is that it is a very simple modular system. The system comprises of no more than 2 types of aquifer blocks in a range of sizes, with only 2 types of density and a few types of fittings. Yet these cleverly combine to provide endless scalability, configuration versatility and installation flexibility. Scalable from a few aquifer blocks used as a soakaway under a domestic flowerbed to dozens of blocks connected in modules, or even hundreds of blocks interconnected in multiple arrays for major civil engineering projects. Almost limitless configuration enables design of all manner of purpose-built systems, capable of providing optimised solutions for the specific operational requirements of projects and users. Flexibility in installation enables ready accommodation for the most difficult and challenging of new build and retrofit sites, including those with limited access, constricted space, high water table and complex buried existing infrastructure such as pipes with cables. Let's look at another unique key feature, the internal circulatory system. This video shows the assembly of an Aquifer SuDS module. The module is assembled from 3 columns of parallel touching, buffering and drainage aquifer blocks, each having a water circulation channel running through its length. The 2 outer columns are connected by 2 flexible pipes to the inlet drain, with a single flexible pipe connecting the 2 outer columns at the other end. This provides a looped circulation system, enabling the very fast water filling required to buffer a major 30-year rainfall event. Water soaking down into outer columns of aquifer blocks is rapidly absorbed into the centre column. Rapid water ingress into the module purges the 94% air from the aquifer blocks through a snorkel pipe connected from one end of the central column of blocks to surface vent. The circulatory system is also designed to enable non-disruptive cleaning of the module's water circulation channels through the simple jetting of water by hosepipe around the system. This would only be necessary in the unlikely circumstance of the cleaning filter not being properly replaced into the inlet drain, which may enable leaves or some sediment to enter the module. In any case, the geotextile membrane wrapped around each aquifer block would ensure that they continued to operate properly. Another unique feature of aquifer blocks is their ability to form a unitary aquifer. By this we mean 2 separate but touching aquifer blocks immediately and freely pass water between themselves, acting as a single unified aquifer. Similarly, 2 blocks placed apart but connected with a flexible pipe will also freely move water between themselves and act as a unitary aquifer. This capability provides 4 very valuable benefits. First, aquifer blocks connected by flexible tubing readily convey water around the natural SuDS system over quite considerable distances if required, releasing it where the soil requires it most, thereby maintaining optimal soil-water balance across a wide area. Second, long lines of aquifer blocks can be used to drain unwanted surface and subsurface water in one place and transport it elsewhere on a site. These not only act as a conduit, but as part of the buffering capacity of the system and provide infiltration. Third, touching aquifer blocks can move water around corners. This enables natural SuDS drainage systems to readily accommodate difficult sites with unmovable existing obstacles. This is a significant benefit when retrofitting or when maximising the use of small spaces on a site that could have been used for SuDS in the past. The fourth benefit comes from the ability to readily increase aquifer capacity to the desired volume by simply abutting additional or larger aquifer blocks. The ability of aquifer blocks to form a unitary aquifer has enabled the creation of ClaySolve. ClaySolve is HydroRock's unique proprietary system for infiltrating through impermeable top layers, such as clay. ClaySolve uses boreholes down into the permeable substrate, filled with specially designed vertical aquifer blocks, to connect and form a unitary aquifer with horizontal aquifer blocks placed on a sand layer in a trench above. ClaySolve enables rainwater to be retained and responsibly managed on site, thereby mimicking nature and maintaining the natural water cycle. The unique feature of aquifer blocks is that they are solid. Until now, the need for high-volume absorbency and rapid attenuation of stormwater meant installing large underground voids in the form of crated sumps. These voids required placement well away from buildings and created large construction exclusion zones on sites, as well as almost arid areas on the surface. This unique feature of aquifer blocks makes the need for underground voids unnecessary, while also providing 4 additional major benefits. First, smaller-sized aquifer blocks can be placed directly up against buildings, providing an excellent protection barrier against stormwater ingress or from immediately adjacent impermeable areas such as patios. Second, large-size modules of aquifer blocks can be positioned within a few metres of buildings, far closer than current UK regulations allow for alternative systems involving underground voids. Third, the removal of the need for large construction exclusion zones on sites enables optimisation of space for construction and simplification of the runs of underground drainage pipes. Fourth, the aquifer blocks keep the soil both on top and around the blocks in optimal water balance. No supersaturation or desiccation of the soil. That brings us to a close of episode 2. Just to recap, in this episode we've explored many of the unique features and benefits of natural aquifer SuDS. The major advantages are a minimum 20% cheaper on overall installed cost, effectively buffers and infiltrates rainwater, truly green, made from mineral wool, even the labels are biodegradable, filters and cleans runoff water, unique water absorption and suspension qualities, retains and infiltrates water on site due to its modularity. Join us in episode 3, where we will be looking at industrial sector applicability of natural aquifer SuDS, exploring a few of the different natural aquifer SuDS systems and looking at some real-life examples of uses within projects, including attenuation, infiltration, clay solve, drainage, rainwater harvesting and irrigation. Thank you for participating in this CPD. If you have any questions or would like more information, please send us an email or give us a call, or stick around for part 3.